Okay, so welcome to part 4 of Unit 4, Lesson 2, Linear Relations. And what we're going to talk about today, or in this portion of the video, is table of values chart. Is it linear or not? We're able to look at a graph and know that it's linear because it forms a line. But we also have to be able to look at a table of values chart and know that it's linear as well. So remember, a linear relation always has a constant change in one variable where there's a constant change in the other. So when we're given a table of values chart, we're looking for that constant change in both of those variables. So let's take a look. Now in your little booklet I give you, your table is horizontal, but that's okay. If you don't like it horizontal, just put it vertical like the one on my graph or on my page. And the first question is, does the table represent a linear relation? Well, let's look at the rate of change. Here we're adding 1. Here we're adding 1. Here we're adding 1. And you're always adding 1 to your x's. Here we're adding 9. Here we're adding 9. Here we're adding 9. And here we're adding 9. So we're always adding 9 with the y's. So since we have a constant rate of change in both of the variables, the answer is yes. And if it is linear, describe it. So as, well, the x coordinate increases by 1, the y coordinate increases by 9. So there's your description. I put my my x and my y, my x and my y in quotations just because I don't want to italicize them, and all variables have to be italicized. So it just is a little bit faster for me to type to put it in quotations. So if the relation is not linear, explain how you know. It is linear, so we can skip that question. And then we want to graph the relation. So my axes are already there. We always know that your horizontal axis is your x1, typically when there's no context to the question, and your vertical axis is your y-axis. We know next is how do you scale this. We're going from 1 to 5. So I'm going to scale it by 1s, but I'm going to go up every 2. So every second one. And the reason why I'm doing this is just to stretch out the graph so that the graph the points, the linear relation is graphed using the most of the grid paper. So we have 4 to 40 here. So let's see if I go 5, 10, 15, 20, 25, 30. I can't do that. So I'm going to go 10, 20, 30, 40, and that should be about good. Okay. So now I have 1, 4, so that should be about right there. 2, 13, about right there. 3, 22, about there. And you can start to see that it's forming a line. 4, 31, and 5, 40. Since it's contextual, there's no context to the pieces of data, we do connect the dots. All of those, when there is no context, we assume that it's continuous and we would connect the dots. Okay. So here's a quick check if you want to stop the video and try this one and then resume, and I'll work through it with you. So welcome back. So does the table represent a linear relation? Well, let's see. So here we're subtracting 1, subtracting 1. We're always subtracting 1 with the x, so that is still, even though you're subtracting, it's still a constant rate of change. And here we're adding 3, adding 3. So we're always adding 3. So we do have a constant rate of change in both of our variables. So it does represent a linear relation. Okay. So if the relation is linear, describe it. So as the x coordinate, wow, decreases by 1. Wow, I'm having a hard time typing right now. Decreases by 1. The y coordinate increases by 3. Okay, so there would be your description. So we don't have to answer this question. And then it says graph the relation and how does it verify? Okay, so we know that the x coordinates, I know my biggest value is 9, my smallest value is 5, so we're going to have to go up by 2's. 4, 6, 8, 10. Again, we have to label our axes. I should have done that first, so x and y. And we go from 8 to 20, so I'm going to go up by 5's. I'm just stretching out my graph as much as I can. You can scale it in a different way as long as you scale it properly. So here we have 9 and then 8. Where am I? 9 and then 8 would be around here. 8 and then 11. 7 and then 14 should be about right there. And I can already see that this one's a little bit off, but that's okay. We're never going to be perfect on these examples. I'm just going to erase that one though, because that one is a little bit off. So that one would be closer to here, because that would be 17.5. So that means that this one would be up just a touch. So let's just fix it. So 8, 11 should be about, oh yeah, about there. That looks way better. And then we got the 6 and the 5 and the 20. Yeah, that looks really, really good. Okay, so since we have no context to this question, we know we have to connect the dots. And we do extend it on either side. If you want to put arrows, you can. But you should extend it. And make sure that it actually goes through the points. I'm just going to change the slope there, just a touch. There, that's a little bit better. It goes through the points. Okay. And there's our graph. It doesn't just stop at those points. It does continue on. Okay, so class notes. Graphing a linear relation from a table of values. Remember, a line is infinitely many points, so close together that they form a line. A table of values gives only a few of those points, and so we can use these to draw the graph. So here we have an x and a y, and we have some values, and it's asking us to graph the table below. Well, since now we have negatives in our data, we need to put our axes now in the middle of the graph. So we always have to kind of be aware of what we have, the data that we have. And sometimes we have to use our common sense. And we're going to get to a couple of those coming up. So our x coordinates go from -2 to +3. So let's just, I'm just going to label it by 1s. I'm just going to put every second point on here, or label. And I'm going to label these by 2s because I don't think I'd have enough room if I labeled it by 1s. So this would be 2, 4, 6, 8. It's just I'm not going to put a label or a number on each of these because then it kind of gets a little messy. So -4, -8. Okay, so that should give me all of my data. Now, one thing in class that happened in class, this line right here is not a negative. It just tells me that I'm using this that's +4. So I just wanted to clarify that. So now I start at the origin, and I go -2, -7. So right there. -1, -4. So -1, -4 is right here. Went right on my label. That's okay. 0, -1 is there. Ooh, is it? Nope. Let me just change that. Because that would be 2, so this would be 1 up right here. My apologies. And 1, 2 would be right here. I have to watch my scale. 2 and then 5 would be right here. And then 3 and 8. And you'll know if you plotted one wrong, because if I go and I draw my line, if 1 point's off, you'll know. There you go. And once again, you can put arrows on the end to say that it does continue on. That pattern will continue on. Okay, so we have a few more here. I'm just going to continue on this movie, or on this video. It's going to be a little bit longer. Here now we have context. So there's a couple things we have to think about before we can even start our graph. First of all, what we have to think about is where do I put my axes first of all? So do I have to put it in the middle like the last example, or do I put it along the sides? So you have to ask yourself, does negatives make sense? Do negative numbers make sense in this example? So we're talking about the number of dairy cows and the annual cost. And since you could never have a negative number of dairy cows, I know I don't have to include the negative side. And same thing with dollars. Unless we're owing, but it looks like this is increasing in value. So we would never have to include the negative sign there. Okay. So now the next question is, we have to put a title, obviously. So we have total cost of dairy cows. That would pretty much explain what we're graphing, and that's really important. And then the next thing, we have to figure out which piece of data goes on which axis. So the independent variable goes on the horizontal and the dependent goes on the vertical. So again, we have to ask ourselves, does the number of dairy cows depend on the total annual cost? Or does the total annual cost depend on the number of dairy cows? And the second statement is actually the one that makes the most sense. The total annual cost depends on how many cows you have. So I am going to put in my labels, number of cows, and I am going to put total annual cost, and I have to put my units in this one, and then I'm just going to flip it around. I wonder, there. You do have to put your units so that you know that you're not talking yen or euros or pesos or whatever. You do actually have to put your units. Okay? Dependent variable always goes on the vertical, and the independent goes on the horizontal. So the next thing you have to ask yourself is, how many how do I scale it? So on my horizontal, or my number of dairy cows, I go from 0 to 50. So I'm going to scale these by tens. That uses quite a bit of the grid paper, or the Cartesian plane. Okay, and here, now we talked about the little squiggly and then starting. That's really good in science. In math, not so good. Okay, there's very few examples that include the little squiggly. So but what it's basically saying is, I'm not going to include anything from 0 to 1,000,000, and then I'm going to start at 1,000,000. In grade 9, you won't have any examples that need the squigglies. Maybe in grade 10, maybe some of your teachers, in high school, some of your teachers might like that, but none in grade 9. So I have to go from 68,000 or 0 to 213,000. So I'm going to scale it by 500,000s. Okay, so what we can do is we can actually change this. I'm going to change this, And I don't want to write thousands out. So what I'm going to do is I'm going to put thousands of dollars. So I'm just going to change my label to make sure that I don't have to write out all those numbers or all those zeros on my thing. So each of them is going to be thousands. So I'm going to have 50,000, 100,000, 150, 200, 250, 300. Okay. Now we just do the best we can with our labeling because it's not going to be very accurate. So we have 0.68, so about right there. I'm going to put it in a different color just so that you guys can see it. So with no cows, we have a startup cost, or our fixed cost, of $68,688. When we have 10 cows, we're at about 97, so we're almost at 100,000. 20 is 126, so about right there, because that's 125. 30 is 155, so about right there, just over 150. 40 is 184. Ooh, so about right there, because I'm just following now the pattern. And now 50 is 213. And that's about right there. Okay, because that's 200. Not, I thought it was 220, but it's 200. So now we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Like in between, it makes sense. Even though we don't have the decimals, we still would connect the dots. Because in between, it still does make sense. Unless it said something like you can only purchase cows in groups of 10, which is not true. So in this example, this one's a little bit tougher because we are talking about discrete data in the number of cows. But since we scaled it differently, we can have 1, 2, 3, 4, 5, 6 cows as well. So this one I would accept probably both answers, where you can either connect the dots or not connect the dots. And there you go. So here's a quick check. So just pause the video and then come back and check and make sure you got it correct. So here, an average price of a gallon of milk and the quantity of milk sold per week. So let's title the graph first. So we have, the graph is going to explain average price versus quantity of milk. Okay, because once you, or sold, I should put sold, because the more you sell, you can decrease the cost a little bit. Okay, or the higher the price, the least you're going to sell. Either one. Okay, so now we need to know, it doesn't make any sense for us to have in the negatives. So let's put our axes, because we will never, now I have red axes, that's okay. It doesn't make sense to have a negative number of milk gallons sold, and we're never going to pay a negative amount of money in order to buy milk. So the negatives don't make sense in this situation. So we're just going to show the first quadrant, or the first, of the Cartesian plane. So now we have to say which one's the dependent one and which one's the independent. So we say the two statements out loud. Does the average price of a gallon of milk depend on the quantity of milk sold per week? Or does the quantity of milk sold per week depend on the average price of gallon of milk? Now both of them make sense, but the second statement makes the most sense. So if you increase the price of the milk, chances are less is going to be sold. So the quantity of milk sold depends on the average price. Okay, so we're going to actually put the average price here, and we are going to put a $sign because it's in milk. Oh, per gallon, sorry, I need to put a per gallon there. And I'm just going to put this here, quantity And since we have milk in the title, we don't have to put it, but we do have to put thousands of gallons. So we actually have to put that there is thousands of gallons. And we're just going to flip this over here and put it. Let's see, can I move this whole thing over? Yeah, I'm just going to move that over so I can move that over. Okay, so we labeled our axes. And then we go from 1.5 to 3.5 along our x-axis. So let's label these as 50 cents. Let's see if I can get all of them in. 150, 2. Yeah, I should be able to get them. 250, 3, and 350. So I just get all of it in. And here I go from 0 to 125. So I am going to go, let's see, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. That's not going to work. So I'm going to go, let's see, 10, 20, 30, 40. That's what I just did, sorry. So I'm going to go this 20, 40, 60, 80, 100, 120, and 140. Okay, so that's pretty good. I'm just going to change my color there just to plot the points. So $1.50 gives you sell about right there, 125. $2 is about 115. So this would be 115 right there. Oh, no. Is it a Friday afternoon? It'll be right in between. Sorry about that. So this is 110, that's 115. So this is 250, 105, so it should be right there. Perfect. See, now we're getting that straight line. 3 and 95. Right there. And 350 and 85. Okay, so in this example, we have to say, does it make sense to connect the dots? Here it says average price. So since it says average price, we would leave the dots unconnected or not connected. And the reason being is because whenever you're talking about the average price of something, that means that you've already taken all the numbers in between and averaged them out. So in this case, we don't want everything in between them because we've done that. We've calculated the average. So we would actually, this is actually discrete data, and we would keep it not, we would keep them just as points. So class notes, graphing a linear relation from an equation. Remember, we can create a table of values from any equation. So when we graph a linear relation from an equation, it's easiest to create a table of values chart. So we did do these actually, you know what? I'm going to do a part 5 to this. So we're going to come back to this because I'm noticing I have about 8 more slides, and this is already getting quite a long video. So I'm going to come back and I'm going to do a part 5.